Okay, so let's take a quick look at our syllabus before we jump into our first day of differential equations. Okay, so I've got, you all know when and where we meet since you're here. My studio hours and office hours are listed. You can also email me anytime. There is an automatic response going out from my email that says I might not write you back because the faculty and staff are all on work to rule because of contract negotiations. So, but I will write you back. So just, it's sort of more of a statement than a practice. So the textbook is called Differential Equations by Blanchard, Devaney, and Hall. You can use a previous edition if you can find one cheaper, but you'll have to do a little translating to figure out what homework problems that I assigned in the 4th edition where they live in a previous edition. And you need to have access to some kind of graphing technology. A graphing calculator is probably actually not going to be that helpful. The technology that might be more helpful would be like a GeoGebra or a graphing program like that on a computer. We'll talk about what differential equations are in a minute, so we're going to skip that. So what to expect in class. So it's going to be almost exactly the same as last semester for those of you who were here. If you weren't in linear, then then we'll go over it a little bit. There's one small change from last semester. You're not going to hand your homework in. You're just going to show it to me in like the 5 minutes before class starts. So we have not very much time to go over homework questions in class. If you have questions, come to class early. I have an office hour, the half hour before class, so I'll either be here early or in my office if you have questions. So each class, I will check off your homework. If you don't get here early enough to show me your homework, then you can show me after class, not a big deal. Each class is going to start with a 2-minute quiz on the assigned reading, just like last semester. After we go over the quiz together, I'll introduce some new concepts. Hopefully, my part where I'm introducing new stuff will be somewhere in the 15 to 20-minute range, but can't make any promises. And then the bulk of the class will be spent working on some problems that I created for you to practice, but not just practice, because I can't possibly tell you everything in 15 to 20 minutes. So it's going to really like develop all the rest of the stuff that was in the reading. And then at the end of each class notes, you'll find learning objectives, a homework assignment, and a reading assignment. So you guys know how to conduct yourselves and not cheat, so we'll skip that. Resources. There's definitely me and each other are like really big resources. Moodle has everything that I ever give you is posted up here in Moodle. So right now we've got the syllabus. The 3 packets are already up. There's a playlist of videos from class, and then there's a playlist of last time I taught it. Those videos are up too. They might be different in like, you know, a teeny bit different, like I fixed a typo or something, but they're mostly the same. And then when we get there, I'll tell you about the final exam and stuff. Right now that's all hidden, but I'll let you see it when we get closer. All right. The math studio, definitely go there. Sandy has a lot of hours and she has taught differential equations before, so she can answer questions there. I'm in there 8 to 8:30 Monday, Wednesday, Friday. And Ian, who also has taught differential equations before, does not have any studio hours this semester, but if you're super nice to him, he might answer questions sometimes. Okay. Peer tutors, basically, that's just you guys once you get to this level, so just make friends. Smart Thinking is an online tutoring service. You can try that out. All my stuff in YouTube, you can go to my channel, and there's also a link to our class, to our playlists. Oh, you do? Oh, good to know. Thank you. Good to know. All right, so for your grade, it's going to be based on attendance, your reading score, which are the daily quizzes, not entirely the daily quizzes, but partly based on the daily quizzes. So attendance, reading score, homework, quizzes, exams, and the final exam / project. Right? So for attendance, you get a perfect attendance score for every class that you show up, work well with your table mates, work through the activities that I give you, and have a productive class. I'll drop 3 at the end of the semester so you can miss 3 classes without any penalty. Reading score, so that is based on reading and creating a question for a quiz and then taking the quiz. Okay, so basically for every class I'll assign you a section of the textbook to read. When you'll read it, preferably take notes on it, and write one really easy to answer question based on the reading, right? It can just be about vocabulary, simple concept, right? One simple question on a note card, put your answer on the back of the note card, label it with your name in the section, and when you come into class the next day, everybody gives me their note cards, and I pick 3 questions to be the reading quiz. Okay?
Yeah, unless they're really bad.
Yeah, unless I pick 3 of my own, right? Well, I want them to be easy, but also capture what was in the reading. All right, so your reading score is based out of 4 points each day. How does it work? One of them is for writing your question. One of them is for writing your question. There are 3 questions on the quiz, so you get a point for each one you get right. So that's 4. And then if you took notes, you get a freebie. You can't get 5. The most you can get is 4, but you could get a question wrong and still get a 4 if you took notes. Yeah. All right. And then later in the syllabus, I have that all written out of how that works. I'll remind you before you leave today. So for homework, most classes you'll get a homework assignment, do the next class meeting, but I will accept it for full credit up to a week late. And I'm just going to come around and look at your homework briefly before each class starts. And again, I will drop 3 so you can miss 3 assignments without penalty. So your quizzes are take-home quizzes this semester. They're all going to be take-home quizzes. There are 6 of them. The dates are all on the calendar. And yes.
I didn't want to revise your calendar, actually. You can barely read.
Yeah, I gave you the yellow one because that one didn't print. Yeah. It didn't print properly, so that's why I printed the yellow one. Yep. I'll drop 1 quiz grade at the end of the semester. For exams, there's only going to be 2. And each exam can take material from the previous exams. They're in-class, individual. The technology allowed for exams may vary, and you can borrow it from me if you need to, and I'll let you know when tests get closer what you're allowed. For both of the exams, you can bring a 1 page of notes of your own creation. And then the final exam is a dual take-home final / project. And we'll talk about the schedule and why it is the way it is in a minute. So your grade, I'll calculate it 2 different ways and give you the better of the 2. You don't have to choose one. I just do it both ways and give you which one's better. So those are the percentages. Makeup policy, quizzes and attendance cannot be made up. If you're absent, if you're not here and a quiz is due, you're going to get a 0 unless you email it to me, right? So you can submit it electronically if you're sick and you can't get here to bring it in. And then homework up to a week late, and tests, you need a good reason. If you were sick, just contact me as soon as you can, and we can do a makeup. Otherwise, it's a 0. Just let me know what's going on. We'll figure it out. If you have any kind of special needs or accommodations, let me know. Here's the more specific directions on the reading assignments and the reading score. So you must read the section, you must create a question, put it on a note card and give it to me the next class. You must take the quiz, and then optionally you can take notes. 4 points maximum on each. Okay, so why did that just do that? Yeah.
You said you're going to determine what kind of technology.
Yeah.
Okay, because before that you had said that a graphic calculator is.
Yeah, it's probably not.
So
Yeah.
we'll be able to use laptops or.
Doubtful. It'll probably just be scientific calculator, or you could use a graphing calculator if you have one, because it's not going to help. Yeah. Yeah. Okay, if you miss a reading quiz, your options are to do nothing and get a 0 for that quiz. I do drop 3, so you can just take the 0 and it won't hurt you as long as you don't do that too much, right? Or you can show me your notes and your question, and you can get 2 out of the 4 points. Okay. Yeah, you can't use it on a test, but I can lend you one for a test if you need that. All right, yeah, and then my schedule printed terribly on the syllabus, so I printed you another one. It's on yellow paper. All right, so here we are, first day. There's no homework tonight, but you do have to read section 1.1 and be prepared for the quiz on 1.1 next class. So you'll read 1.1, write a question, come in and take the quiz. So all your homework is listed here for the semester. All your reading assignments are listed to the right. The dates of each take-home quiz are posted, and then the dates of the tests. So what you should notice here is that we are finished. What is wrong with this? Yeah. We're finished with new material on April 22nd. So if you were in my class last semester, you know that I'm pregnant. I'm have it due April 27th. So we're hopefully going to finish before that. And I have written a take-home final and a project for you to finish in the last 2 to 3 weeks of the semester. Yes.
Is that on new material that we learned after that, or is that on all the material?
The project the final stuff, it's on the whole semester.
But after you leave us,
there is no new material after I leave you. We're gonna get through the whole course and or fast. Yeah. Yeah. Well, that's why we're having only take-home quizzes and only 2 tests. That was part of how I compressed it. Yeah. No snow days. Yeah. Yeah. So I don't have any allowance for snow days. Yeah, so before that happens, I have review days for test 1 and test 2. We can eliminate those. So we have 2 days that we could possibly use to deal with a snow day. And then after that, I'm going to have to ask you to watch a video on your own to make up the class. All right, so for the project, I have left solutions with Ian and Sandy and Bob McGuigan. So yeah. So if you need a resource, somebody to talk, an instructor to bounce an idea off of or whatever, first I strongly encourage you to use each other, like talk about it, collaborate. You can email me, right? I'm still going to be alive, right? But you can also see Ian or Sandy or Bob. So that's the plan. Questions? Yeah. Yes. Yes. Correct. Yeah. So there's no homework assigned tonight. Friday, I'll assign some homework from 1.1. Yeah. Reading from 1.1 is due Friday. Yeah. Also, if you haven't been in my class before, these folders are how I take attendance. Just put your name over one of the rectangles and you just check off each day that you're here. You'll put your take-home quizzes in there when they're due. Okay, so let's talk about differential equations. All right, so what is a differential equation? It's an equation that has a derivative in it, at least one derivative. So a solution to a differential equation is a function. So a solution to a differential equation is a function that makes the equation true. So this is different than any kind of equation you've solved before because typically solutions to equations are numbers, right? But now they're going to be functions. So what function makes this differential equation true? dy dx equals sine of x plus 2. Yes. So, I need to. That was a little bit off. I just fixed it yesterday before I left. Okay, so a function y equals, the antiderivative of sine would be negative cosine, antiderivative of 2 is 2x, and then you could put a plus c because the derivative of any constant would be 0. So that's a function y, so that dy dx is sine of x plus 2. In fact, that's a whole family of functions. Not really. I mean, you got to be careful. We'll talk about it when it comes up. So this is a whole family of functions that makes that differential equation true. To obtain a unique solution, right? Because there are infinitely many solutions that make that true. To obtain a unique one, you need another piece of information. You need an initial value. Okay, so we call this an initial value problem when I give you a differential equation plus an initial value, right? So plus, I know that y of 3 is 5. So if I want the particular solution that satisfies the differential equation and the initial value, well, I say, okay, well, y of 3, plug a 3 in for all my x, and I get negative cosine of 3 plus 2 times 3 plus c has to equal 5, according to this given information. And then you just solve for the c. So c is going to be 5 minus 6 is negative 1. This is going to be the cosine of 3 minus 1. Yes?
Isn't one of the solutions to use like square root or minus like square as one of the solutions? Yes.
I don't. One of the solutions to what?
You mentioned about entity, the trig sums for
There's only one antiderivative of sine x. I don't know what you're referring to.
the trig substitutions. When a function was the square root of
Oh. Yeah, you only do that when there's a square root.
it doesn't work in reversal.
No, I mean, there's only one antiderivative of sine x. There is no other function whose antiderivative is sine x. Yeah. We are going to practice some anti-differentiation techniques because we clearly just did some anti-differentiation. So we're going to practice it. But for right now, we're just keeping it simple. Overall concepts. Yes. Yeah. Yeah. Okay, so it's tempting to just circle C as your answer, but remember the answer is always a function. So the solution to the initial value problem is the function negative cosine x plus 2x plus the cosine of 3 minus 1. So it's the general solution. I just replaced the c with what we solved for when we used the initial value. All right, so given a differential equation that is simple enough, we can come up with a solution right away, right? But if you have a more complicated differential equation, like 4x squared times the second derivative of y plus 12x times the first derivative of y plus 3y equals 0, we don't have tools to solve this yet, right? But we can quite easily check if a solution is actually a solution, right? I propose that x to the negative 3/2 is a solution to that differential equation. I can show that it actually is the same way you would for a regular equation, right? If I wanted to show that x equals 2 is a solution to 2x equals 4, what do? You plug it in, right? So I'm just going to plug it in here. So this is a y, and in my equation I have a y double prime, a y prime, and a y. I have to plug those all in. So I know y is x to the negative 3/2. What's y prime? Yep. And then y double prime? Negative 7/2. Okay. So I now have y prime, and y double prime. Plug them into that equation and show that it is true. All right, so I have 4x squared times y double prime, which is 15/4 x to the negative 7/2. Okay. Then I have plus 12x times y prime, which is negative 3/2 x to the negative 5/2, plus 3 times y, which is x to the negative 3/2. Does that actually equal 0? Once we plug it in, do these two sides actually equal each other? So now you just do a little algebra simplification. So these 4's cancel. And I have 15. What's x squared times x to the negative 7/2? Oh, no. When you have like bases, you add the exponents. X to the negative 3/2. Right? The 2 is 4/2. 4/2 plus negative 7/2, negative 3/2. All right, now negative 3/2 times 12 is negative 18. And then x to the first times x to the negative 5/2, x to the negative 3/2. And then I have plus 3x to the negative 3/2. That does, in fact, add up to 0. It became all like terms, 15 minus 18 plus 3. Yeah, for x's that are positive, yeah. So whenever, this is like the beauty of differential equations, you will always be able to check if your answer is right when you're solving a differential equation. Sometimes it's messy, right? Sometimes the algebra is messy, but you can always take what you think is the solution and plug it into the original equation and see if it's true. Okay, so part of why most of you are taking differential equations is because it's really useful to model real-world stuff. Okay, so when we're describing a physical situation with a differential equation, we call that modeling. And we're going to look at modeling several times throughout this class. And here are the 3 basic steps. You have to think about what are your underlying assumptions, meaning if you're trying to model something in the natural world, there are things that you know about that and that you are assuming. Okay. Identify all relevant variables and parameters, and then use your assumptions from step 1 to formulate an equation that relate all the variables you defined in step 2. Okay, so if we wanted to model the US population, here's a graph population. I think that's in millions from the year 1800. So our first model that we're going to look at is a really common population growth model, really simple model called the Malthusian Model. And the assumption is that the growth rate of a population is proportional to the size of the population. And it seems like a reasonable assumption, okay? Because as a population gets bigger, the members of the population interact with each other more, they reproduce more frequently, right? So the growth rate grows in proportion to the size of the population. Bigger the population, faster the growth rate. All right, so given this assumption, what variables are we talking about here? Time, okay, so we'll have T be time. We'll have P be population size. Good. Okay, so those are our important variables. And then the Malthusian model, if I was going to translate our assumption into an equation, growth rate, how would I translate P and T into a growth rate? P prime or dP dt, yep. You know, the rate of change of the population, dP dt, is equal sign proportional to the size of the population, right? The size of the population is P. How do you say that something is proportional? Yeah, you have some scalar, you have some constant of proportionality. We'll call it K, P. Mm-hmm. Yep. So that's a differential equation, okay, that models population size given this very simplistic assumption about how populations grow. As we work through the course, we're going to add more and more layers of assumptions to try to make more sophisticated models. This differential equation is called a first order equation because it contains only a first derivative. Okay, when there are second derivatives, we call it a second order differential equation. And we call it an ordinary differential equation because it doesn't contain any partial derivatives, right? So if you've taken Calc 3, you know what partial derivatives are. In this class, we're only going to deal with ODEs. We're going to have no partial derivatives in this class. All right, so let's confirm that P of t equals 0. That's a function, right? The function that's 0, right? P of t equals 0. So the population is always 0. Okay? We want to show that that's a solution to the Malthusian model, which means just plug in, right? So P of t equals 0. So I want to plug that into dP dt equals Kp. Well, if P of t is 0, what is dP dt? 0. The derivative of 0 is 0. K times P, which is always 0. Is that true? Yeah. Okay. So that is definitely a solution. Okay. This special type of solution is called an equilibrium solution. In a population model, in this population model, it corresponds to a non-existent population. If there are no members of the population, it will never grow. It will never shrink. Nothing ever happens. There's just always 0. Okay, so that's it for my intro. I'm going to have you play around with some activities.